In this video, we're going to be explaining how to find the area of any regular polygon. A regular polygon is a polygon with all equal sides. So every shape that we talk about in this video is going to have equal side lengths. First thing we want to do is define a few words. The radius of a polygon is pretty similar to the radius of a circle in that it comes from the center of the shape. The only difference in a polygon is that the radius is going to connect to a vertex. So it's the length or distance from the center of the shape to one of its vertices. It's also going to bisect that vertex angle. So whatever this vertex angle is, this radius is going to cut it into two equal halves on either side there. And we're going to use that property. An apothem, it's maybe a new word. It's actually the length from the center of a shape to the midpoint of one of its sides. So if it's hitting the midpoint over here, it's going to bisect that side length into two equal halves. So we have a radius, we have an apothem, and as you can see, we are drawing a right triangle here. And so properties of a right triangle are going to allow us to find these lengths that we need so that we can plug it into this formula. To find the area of any regular polygon, all we have to do is take that apothem length and multiply it by its perimeter and divide by 2. So this pentagon is kind of complicated. We'll come back to that one. Let's start with a shape that we kind of already know how to find the area of. So here we have an equilateral triangle. We know that we could find the height of this triangle and do base times height divided by 2. That's one way to find the area. But let's see how we can use this new formula to get the exact same area. So we're given the side lengths. If we know that the entire side length is 8 times the square root of 3, this apothem is going to bisect one of its side lengths. So let's say that half of 8 times the square root of 3 is 4 times the square root of 3. Let's draw our radius, so from the center to the vertex. So now we have a right triangle. Let's figure out what type of right triangle it is. Well, in an equilateral triangle, all vertex angles are 60 degrees. So if this radius is cutting that in half or bisecting it, then we just created two 30-degree angles right here. If we drew a right triangle and one of its angles is 30, the other complementary angle must be 60. So this is our special 30, 60, 90 triangles, and they're created by drawing an apothem and a radius in an equilateral triangle. That will always be true. So if we know the properties of a 30, 60, 90, we can use those properties. The side length across from the 60-degree angle is considered the longer leg of the two legs. If that length is 4 times the square root of 3, well, the short leg would just be 4, because the short leg times the square root of 3 is the long leg. So if this value is being multiplied by the square root of 3, the short leg must be that value in front. So now we know our apothem length. That's part of what we need. We also need the perimeter. We already know the side length. We could triple that. Multiply one side length by 3 and get 24 times the square root of 3. So now we have the two values we need. We have our apothem and we have our perimeter. Let's multiply those two things and divide by 2. You could divide first if you want. Simplify our multiplication here. And so the area is 48 times the square root of 3, or approximately 83.1 square centimeters. And if you were to find the height of this triangle and do base times height divided by 2, you would find the exact same area measurement. Let's do another one that we're pretty comfortable with. Let's look at a square. We know that the area of a square is just squaring the side lengths. So we know that the area of this should be 12 squared, or 144 square feet. Let's see how we can use this new formula to get the exact same answer. If we draw an apothem, that's going to bisect our side length. So instead of 12, we now have two pieces of 6 feet. And we could draw a radius, which is going to bisect our vertex angle, in a square that's 90 degrees. So if we cut it in half, we just created two 45-degree measurements. So now we have a right triangle with one of its angles measuring 45 degrees. Its complement must also be 45. So now we know we're dealing with an isosceles right triangle, or a special 45, 45, 90. The legs are going to be equal. So if this length is 6, this length or other leg is also 6. And that's our apothem. So we have our apothem length. Now we just need our perimeter. Well, all the side lengths are the same, so 12 times 4 gives us our perimeter. Our perimeter is 48. So if we multiply the apothem times the perimeter and divide by 2, or divide first to simplify our multiplication, we get the exact same thing we already talked about at the beginning. 144 square feet is its area. So we can see how this formula does work on shapes that we already know different formulas for. But let's start to look at shapes that we don't necessarily have an area formula for. For example, we can go back to this pentagon. We now have to use this polygon area formula. So we're given the side length of this pentagon is 4 inches. We can draw our apothem, which is going to bisect our side length into 2 measurements of 2 inches. And we could draw our radius, which is going to bisect our vertex angle. Well, now we need to figure out what that vertex angle is. In a pentagon, we could find the total number of degrees inside our shape by using this formula that hopefully we're already familiar with. The number of sides minus 2 gives us the number of triangles in that shape. If we multiply that by 180, that will tell us how many degrees are inside our shape. So if we have a 5-sided shape or a pentagon, 5 minus 2 is 3, and 3 times 180 is 540 degrees. So total interior angles add up to 540. They're all equal angles because it's a regular pentagon. So if we divide that total by the number of angles, that'll tell us how much each angle measures. So 540 divided by 5, the number of angles, tells us that each angle is measuring 108 degrees. So if this vertex angle right here is a total of 108 degrees and this radius bisects it, 108 divided by 2 gives us 2 angles that measure 54 degrees. So now we know one of the angles inside our right triangle. We know one of the side lengths. We can use trigonometry to figure out our apothem length. Since we're dealing with the opposite side and the adjacent side relative to this angle, we could use the tangent of 54, set it equal to the opposite side, which is our apothem, over our adjacent side, which is 2. Cross multiply to solve, and we get our apothem length is about 2.753. We could also solve for our radius if we really wanted to. We could use cosine, not necessary to find the area though. So now we can find our perimeter. We know that each side length is 4 inches. There's 5 that are equal side lengths. It's a regular pentagon. So the perimeter is 20 inches. We have our apothem length. Let's multiply those two things and divide by 2. And what we get is our final area of the pentagon, 27.528, or about 27.5 square inches. As you get further in math and you learn about the law of sines and cosines, you can actually come up with a different method to find the area. You can just break these up into the number of triangles and find the area of each triangle. Because it's not a perfect right triangle, you need these formulas, the law of sines or the law of cosines, in order to find those areas. All right, since we got a little bit extra time, we'll do this last example. We now have a 6-sided shape or a hexagon. We can do the exact same thing. If we know the side length, for instance, here we're given 8 meters. We can draw our apothem and bisect that side length into 4 meters. We can find the total number of degrees inside our hexagon. Number of sides minus 2 times 180. So 4 times 180 tells us that 720 degrees are inside this shape. Each of these vertex angles are the exact same measurement. So let's divide that equally into 6 parts. 720 divided by 6 means that each angle is 120 degrees. This radius is going to bisect that vertex angle into 2 measurements of 60 degrees each. So now we can see that we got a special 30, 60, 90. We could use its properties to find that apothem length. Since the short leg across from the 30-degree angle is 4, the long leg is just that value times the square root of 3. And since I'm running out of time, you can look at the rest of it to finish it off.